Hello students, in previous class we discussed about the quantum numbers. There are four quantum numbers are there: principal quantum number, angular quantum number, and magnetic momentum quantum number and spin quantum number. So here this quantum number, principal quantum number, is explaining about the shell size and its energy. Okay, this is explaining about the size and the energy of a main shell that is showed by n. N values are n values as present. N values are there from 1 to 3, means n is equals to 1 2 3 4, like that it will be present. Okay, if n value is increasing, then the shell becomes larger and the electrons in those shells are farther from the nucleus. Okay, so n is equals to 1 to 3 means that often we can represent it as k, l, m, n, like that. Okay, for example, in this principal quantum number, shells are represented by small n. If n is equals to 1, that is k shell. If n is equals to, that is l shell. If n is equals to 3, that is m shell. N is equals to 4, that is n shell. Okay, so in this each shell some subshells are there. In each shell some subshells are there that we can know by azimuthal quantum number or angular momentum quantum number. This azimuthal quantum number is proposed by Sommerfeld, and this azimuthal quantum number is showed by L. This azimuthal quantum number is explaining about in each shell how many subshells are there. About that this will explain. Okay, so this azimuthal quantum number will explain in each shell how many subshells are there. About that this will explain. This azimuthal quantum number is showed by L. This L values are start from 0 1 2 3 4, like that. Okay, so here if the L value is 0, that is on that only one subshell is there, that is S subshell. Okay, if L value is 1, in that then the name of the subshell is P. If the L value is 2, then the name of the subshell is D. If the L value is 3, then the name of the subshell is F. Okay, if L value is 0, then the name of the subshell name is S. Okay, if the L value is 1, then the name of the subshell is P. If the L value is 2, then the name of the subshell is T. If the L value is 3, then the name of the subshell name is F. Okay, so L has integer values from 0 to n minus 1. Each value of n, each L value represent one subshell. Okay, so each value of L is related to shape of a particular subshells in the space around the nucleus. Okay, these values of L for a particular subshells are represented by S, P, D, F. Okay, na? So if n is equals to 1, there is only one subshell, that is L is equal to 0, 1s orbital. If n is equals to, in the two subshells that are L is equal to 0, 2s and 2s subshell, and L is equals to 1, that is 2p subshell. It will be there like this. Okay. Next, magnetic quantum number. This magnetic quantum number is proposed by Landé. So this is showed by M, R, M, L. Okay, in that each subshell how many orbitals are there, about that this will explain. Okay, so for certain L values there are 2L plus integer values of ms as follow. Means by depending on the 2L plus 1 formula, how many number of orbitals are there in each shell we can represent. Okay, so this number of orbitals means this magnetic quantum number values are depending on the subshell. Okay, this magnetic quantum number values are depending on the L value. Okay, this ml values are depending on the L values. Okay, by depending on the 12 plus 1 formula, we can say how many number of orbitals are there. This ml values are depending on the L value. L values are start from 0. No, if L is equals to 0, when we substitute in 12 plus 1, then 1 will come. Means in that only L is equal to 0 means in that only one orbital is there, that is S orbital. If L is equals to 1, then that is P orbital, subshell name. So then in that how many orbitals will come? 3 orbitals will come. If L is equals to 2, that subshell name is T. In that how many number of orbitals will come? 5 orbitals will come. If L is equals to 3, then the subshell name is F. In that how many number of orbitals will come? 7 number of orbitals will come. Okay, here one table is there. Okay, once you observe the table, so here principal quantum number So in this, principal quantum number, azimuthal quantum number, magnetic quantum number, and subshell notation given, and the number of orbitals in that subshell also given. Okay. So n, it is explaining about principal quantum number. So this n we are explaining size and size of a orbital. Okay, size of the shell. These n values are explaining about the size and energy of a main shell. These n values are start from n is equal 1 2 3 4. No, n is equals to 1. Okay, so what is its L value? If n is equals to 1, in that only one subshell is there. Okay, the subshells are showed by L, that is 0. Okay, and what is its ml value? Ml value is 0. Okay, then what is the name of that subshell name? 1s. Okay, so how many number of orbitals present in that subshell? Only 1. Means n is equals to 1 means first shell. In that first shell, how many subshells are there? Only one subshells. That L value is 0. And what is its ml value? Ml value also 0. And what is the subshell notation? That is 1s. Okay, and number of orbitals in that subshell only 1, equals to 2. 2 means second main shell. So in that second main shell is, that is L shell. Okay, what is that? That is L shell. Okay, that is n is equals to 2. Okay, so in that how many subshells are there? N is equals to 2 means in that 2 subshells are there. Okay, n is equals to 2 means in that how many subshells are there? 2 subshells are there. What are that? S and P. Means its L values are 0 and 1. Okay, n is equals to 2 means that is second main shell. So in the second main shell, how many subshells are there? 2 subshells are there. What is its L values? 2 subshells, no, first subshell value 0, second subshell value is 1. Okay, what are its magnetic quantum number value? So that 0 is there, no, L value is 0 is there, no, second main shell, that ml value is 0. And in second main shell, L is there, no, 1 is there, no, one more 1 is there, no, means in second main shell 2 subshells are there. What is that? 0 and 1. 0 ml value is 0 and 1 ml values are -1, 0, +1. Okay, so what is the name of that orbital? P orbital. What is the name of that orbital? If in second main shell n is equals to 2, that L values are 0, 1 means in the 2 subshells are there, no, 2 subshells, one is 0, another one subshell L value is 0, another subshell value L is equals to 1, means what are that? S, P. Okay, means it is belongs to second main shell now, that's why 2s, 2p. Okay, so subshell notation what? 2s, 2p. So how many number of orbitals are there in that subshell? In 2s subshell, only one orbital is there. In 2p subshell, how many orbitals are there? 3 orbitals are there. px, py, pz, like that. Okay. Next, n is equals to 3, third main shell. So in the third main shell, how many subshells are there? 3 subshells are there. Okay, what are that? S, P, D. Okay, S, P, D. So what is the L value? Okay, 3 n is equals to 3 means third main shell. In that how many subshells are there? 3 subshells are there. What are its L value? 0, 1, 2. 0, 1, 2. Okay, what are the ml value of this 0, 1, 2? ml value of 0 means in third shell 3 subshells are there, no, in that first shell is 0, that is S, its ml value is 0, and one more subshell is there, that is 1, its ml value is -1, 0, +1, and one more subshell is the more subshell notation is 2. 2 means its ml value is -2, -1, 0, +1, +2. Okay, so in third main shell 3 subshells are there, that L value is 0, 1, 2. Okay, means its L value 0 means that is 3s orbital, and L value is 1 means that is 3p orbital, L value is 2 means that is 3d orbitals. Okay, and in this 3s orbital only one in the 3s subshell only one orbital is there. 3p subshell 3 orbitals are there, px, py, pz like that, and 3d subshell 5 orbitals are there, dxy, dyz, dzx, dx square minus y square and dz square like that. Okay, next fourth shell. Okay, that n is equals to fourth shell. In that fourth shell, how many subshells are there? 4 subshells are there. What are its L value? 0, 1, 2, 3. 0, 1, 2, 3. Okay, so what are the ml value of this 0? 0. What are the ml value of this 1? Minus 1, 0, plus 1. And what are the ml value of this 2? Minus 2, minus 1, 0, plus 1, plus 2. And what are the ml value of this 3? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, and what is the subshell notation in the fourth main shell? How many subshells are there? 4 subshells are there. What is the subshell notation? 0. 0 means that is 4s orbital. 1 means 4p orbital, and its ml values are minus 1, 0, plus 1. Okay, next L is equals to 2 means that is subshell notation is 4d. 4d means in that 5 orbitals are there. What are, okay, 5 orbitals are there. Okay, next n is equals okay, in fourth main shell, that fourth main shell subshell notation is 3. So that ml value was minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So means here how many that what is the subshell notation? 4f. What is the subshell notation? 4f. So in fourth main shell, if L value is 0, in that how many that subshell notation is 4s, and in that how many orbitals are there? 1 orbital there. In fourth main shell, L value is 1 means its ml value is minus 1, 0, plus 1. That subshell notation is 4p, and the number of orbitals in that present in that is 3. Okay, next fourth main shell, what is that? L value is 2. So ml value is minus 2, minus 1, 0, plus 1, plus 2. Subshell notation is 4d. In that 5 orbitals are there. In fourth main shell, subshells 4 are there? No. Subshells 4 means these subshells start from 0, 1, 2, 3, 4 means S, P, D, F. We can call that as. Okay. So in fourth main shell 4 subshells are there, and that subshell notation is 4s, 4p, 4d, 4f. In 4s 1 orbital is there. In 4p 3 orbitals is there. 4d 5 orbitals are there, and 4f 7 orbitals are there. Okay. Each subshell holds a maximum number of pies of many electrons and the number of orbitals in that shell. So the maximum number of electrons that can occupy various subshell is given in the following table. So each subshell, okay, subshell means what? Here S, P, D, F. In angular momentum quantum number we discussed, in each main shell subshells are there. These subshells are represented by L. L values are start from 0, 1, 2, 3, and the name of the subshell is SPDF. If L is equal to 0, that is the name of the subshell name is S. If L is equals to 1, then the name of the subshell is P. If L is equals to 2, the name of the subshell is D. If L is equals to, the name of the subshell is F. Like that we said, no? So about this annular quantum number is explaining, and in each subshell how many number of orbitals are there? About that magnetic quantum number will explain. In S subshell only 1 orbital is there. P subshell 3 orbitals are there. D subshell 5 orbitals are there. F subshell 7 orbitals are there. Okay, about that this will explain. Now in each orbital how many number of electrons we can fill? That we can explain by depending on the 2L plus 1 formula. Once you observe the table 3, each subshell hold maximum of pies of many electrons as the number of orbitals in the shell. Okay, so here subshell name given, number of orbitals given, and the maximum number of electrons also given. So subshell name is S, that L value is 0. So the number of orbitals. How many number of orbitals will be there? That number of orbitals we can show by depending on the 2l plus 1 formula. Means magnetic quantum number is explaining or not? Yes, already we discussed in the magnetic quantum number. Okay, subshell name is S, that L value is 0, and the number of orbitals by depending on the 2l plus 1 formula is 1. So in that one orbital only there. So but each one orbital accommodate 2 electrons. So the maximum number of electrons present in s orbital is 2 electrons. Okay. Next, one more subshell P, and its L value is 1. Okay. So how many number of orbitals are there? In magnetic quantum number we discussed this number of orbitals we can explain by depending on the 2l plus 1 formula. Means in magnetic quantum number showed by ml values are depending on the L values. So if P is equals to P subshell means L is equal P subshell L value is 1. So the number of orbitals by depending on the 12 plus 1 formula we can say that are 3. So 3 orbitals means in each orbital we can fill 2 electrons. Means how many number of electrons we can fill? Double, 6 electrons we can fill. Okay. So understanding or not? Okay. So P subshell, that value is 1. So that how many number of orbitals are there? That number of orbitals we can show by 2l plus 1 formula. Okay. So 2l plus 1 formula, P is in the place of L is equals to 1 substitute. 2 into 1 plus 1 means 3 will come. Okay. So 3 orbitals will be there. So in each orbital 2 electrons we can fill. But here 3 orbitals are there. In each electron 2 electrons we can fill means 3 2s are total 6 electrons we can fill. Okay. Next, D subshell. D subshell, that L value is 2. Okay. How many number of orbitals are there? 5 orbitals are there. 5 orbitals means how many electrons we can fill? 10 electrons we can fill. Okay. Like that we can fill. F subshell. This L value is 3. Okay. How many number of orbitals are there? So by and L is equals to substitute in 2l plus 1 formula. Okay. 2 into 3 plus 1 means 2 3 is 6 plus 1 7. 7 orbitals are there. How many electrons are we can fill? 14 electrons we can fill. Okay. Okay. So this spin quantum number is proposed by Uhlenbeck and Goudsmit, and it is showed by MS. So here the earth is revolving around the sun. At the same time it is complete one rotation on its own axis. So like this earth, electrons are revolving around the nucleus, and at the same time it is complete one rotation around its own axis. So these electrons are moving in clockwise and anti-clockwise direction. So these are showed by upward arrow mark and downward arrow mark. Okay. If the electrons are okay, so for this upward arrow mark, that spin value is plus half, and for downward arrow mark this spin value is minus half. Means in one orbital we can fill 2 electrons, and that we can fill in with that we can fill in opposite direction. About that this spin quantum number will explain. So the 3 quantum numbers N, L and ML means principal quantum number, annular quantum number, magnetic quantum number is describe the size, shape and orientation respectively of the atomic radii in the space. So as you have observed in the case of street lights, sodium vapor lamps, yellow light is emitting. Okay, when we observe the street light, sodium vapors are emitting yellow colored light. This light is comprised of a very close spaced doubles when analyzing using the high resolution spectroscope. So as you observed in the case of street lights, sodium vapor lamps, yellow light is emitted. This yellow light is comprised of a very close spaced doublet when analyzed using high resolution spectroscope. So when we observe the street lights, so in that sodium vapors are there, that is emitting yellow light. So in this yellow light we can observe 2 closely lines. Okay, when we observe with high resolution spectroscope, in this yellow light we can observe 2 double lines. Okay, alkali and alkali earth metal shows such type of lines. Okay, so to account for such behavior of electron, an additional quantum number is introduced. This is spin quantum number. This is represented the property of the electron. It is denoted by ms. Okay, So when we observe the street lights that are emitting yellow light, in that we can observe two closely packed lines. By observing the two closely packed lines, lines, scientists to propose that spin quantum numbers, means in spin quantum number also in one orbital two electrons are we can fill. These two electrons we can fill with opposite direction, like that they said. This spin quantum number is showed by MS, and it is proposed by Uhlenbeck and Gaudsmit.